Welcome back to our biomass class, where we're delving deeper into the fascinating world of conversion of biomass resources into heat and power. This video was made with the support of InnoEnergy. Remember that this biomass energy course has 9 lessons. Lesson 3 has 3 main topics. This first video is an introduction to the topic, providing you a useful overview of lignocellulosic biomass resources. Solid biofuels can be obtained from energy crops, agricultural residues, and forestry. For example, miscanthus is an herbaceous crop, and poplar is a woody crop. Agricultural residues can be field residues from annual crops, process residues, and residues from perennial crop plantations. Forestry can produce timber or residues. The key factors for the analysis of biomass resources are production costs and biomass quality. For energy crops, we will study what are the main energy crops and how should they be managed. For agricultural residues, how are they harvested? How can they be processed? For forestry biomass, how forests can be managed? What becomes fuel biomass? Let's deal first with energy crops. Energy crops are low-cost and low-maintenance crops grown solely for energy production, not for food. The plants are generally categorized as herbaceous or woody. Herbaceous energy crops are mostly types of perennial grasses. Short rotation woody crops include many types of fast-growing trees. Let's focus first in herbaceous crops. This group includes plants like miscanthus, switchgrass, bluestem, elephant grass, and wheatgrass. How crops are managed and processed influences productivity, costs, and biomass quality. When growing herbaceous energy crops, it must be taken into account that after planting, a minimum of 2 to 3 years is required to achieve maximum annual yields. For each species, yields are strongly influenced by annual rainfall frequency and soil water retention. Harvesting is made usually once during the growing season and can take place during the winter or early spring. Miscanthus can be burnt directly in biomass boilers, or processed further into pellets or briquettes. Let's move to woody crops. Woody energy crops are fast-growing hardwood trees that are harvested within 5 to 8 years of plantation. Examples of these crops include hybrid poplar and hybrid willow because they're fast-growing. How are they managed? There are dedicated techniques and equipment for most stages of its tending, from planting to harvesting. Stems can be treated in different ways. Pictures show the direct conversion into wood chips. The large initial investment cost of plantations may be intimidating since there is no financial payback for 4 years from the initial establishment. Let's deal now with agricultural residues. There are different types of agricultural crop residues. In this video, we classify them in 3 groups: field residues from annual crops, process residues, and residues from perennial crop plantations. Field residues are materials left in an agricultural field or orchard after the crop has been harvested, like straw. Process residues are materials left after the crop is processed into a usable resource, like nutshells. Perennial crop plantations generate residues with 2 main activities: pruning during the production cycle and removing at the end of the production cycle. Let's see an example of a field residue used as biomass for energy resource. Straw is an agricultural byproduct consisting of the dry stalks of cereal plants, after the grain and chaff have been removed. Straw is usually gathered and stored in straw bales made directly in the field during harvesting. The use of straw in medium to large-scale biomass power plants is increasing over time. Let's move to process residues. Process residues include husks, seeds, bagasse, molasses, and roots left after the crop is processed into a usable resource. Under favorable circumstances, process residues can be easily used as biomass resource. For example, sugar cane bagasse is used to be burned to provide heat and electricity in sugar mills. Let's move to residues from perennial crop plantations. Perennial crop plantations such as grape and olive generate considerable amounts of woody residues from pruning and replanting activities. Pruning is a practice involving the selective removal of certain parts of a plant, such as branches. Pruning produces small volumes of biomass that are yearly available. There are different techniques and equipment with different costs and productivity for processing pruning residues as well as for removing plants and stumps. Biomass produced from pruning residues is usually of low quality. The biomass generated at the end of the cycle is made up of the entire plant, including the roots. The biomass produced from the aerial part of removed plants can be of high quality and can sprout good market prices. Conversion of stumps into biomass is more complex. However, it can cover the costs of the operation. Let's deal now with forestry biomass. Biomass can be produced from forestry. Productivity, costs, and biomass quality depends on how the forest is managed, how the felled trees are processed, and how wood is converted into biofuels. Forest management is a key issue that influences not only the health of the forest, the minimization of fire risks and sustainability, but the quantity and quality of wood that can be obtained. Forest thinning is a forestry technique that allows a healthy management that can maximize not only the production of wood but also the absorption of carbon dioxide. Main products are trunks and residues like tips and branches. The quality of the biomass depend on what parts of the tree are used to produce it. Harvesting operations include felling, stripping, cutting, hauling, and chipping or crushing. Wrapping up. Sources of biomass can be diverse. Agriculture and forestry can provide biofuels with different quality and production costs. The way of growing plants, harvesting them, and processing products strongly influence productivity, costs, and quality. For more details, please watch the videos about energy crops, agricultural residues, and forestry biomass.